Let us take a look at 2023, Paper 2, Question 1. The coefficient of x power 3 in the expansion of k plus 2x multiplied by 2 minus half x power 6 is 0. Find the value of constant k. Now, for this one here, since we need x power 3 term, and I observe these two terms here, I know that I only need to expand this up to x power 3. So let me just pull this one down, rewrite it, and I'm going to expand this one here. So the first term will be 2 power 6, followed by 6, 1, 2 raised to the power 5, and this one here, just be careful, write back the negative, half x raised to the power 1 plus 6, 2. Now we reduce this power and we increase this one. We have negative 1 over 2x power of 2. And the next term, 6, 3, 2, reduce, increase. So I have power 3 here. Then the next one, I will still have minus half x raised to power of 3. And so on, that we're not going to expand anymore. Let me change this to square bracket. Okay, so let's simplify over here, the expansion of this term here. Let me rewrite this back. So from here, I'll be getting 2 power 6 will be 64. Keying this in my calculator, 61 times 2 power 5 times negative half. I'll be getting a negative 96. X power 1 is x. Next, I'll be keying in my calculator, 62 times 2 power 4 times negative half square. This will give me 60x squared. And this term over here, 63 times 2 power 3 times negative half power 3 will give me negative 20 x power of 3. And so on. So let me focus on checking the x power 3 terms. Now let's start to link. So this one, I will need to link with this term here. That will give me a k times negative 20. Let me just write down, okay? K times negative 20 will leads me to one term in x power 3. I'm just jotting down the coefficient. So let me think about this one here. This is x. I will need to link with this term here to get an x power 3 term. So the coefficient, let me just check here. I'll be multiplying the coefficient of 2 with this, which is 60. And since the question say that it will lead us to coefficient of 0, let me just input 0 over here. Now solving this one here, I'll have negative 20k equals to negative 120. 120 move to the right, so k will be equals to negative 120 divided by negative 20. So I'll be getting a 6 for this question number 1. Question 2, the diagram shows a circle, center C with FD as diameter. The tangent at the point B on the circle meets DF extended at the point A. Point E lies on AB extended, and X is the point of intersection of BD with EC. Part A, prove that triangle ABD is similar to triangle AFB. Now I highlighted the important points and also I have color-coded the angles. Let's check what are those angles. To prove a similar triangle, let's check on the first angle ABD. Let's take a look at the triangle first and locate the angle for A. So I'm going to look at triangle ABD and draw out where is triangle ABD, and we just draw color coding the angle A as green. And I'm going to take a look at triangle AFB. So AFB, I notice is exact same angle, which is the green color there. And I'm going to write down here, common angle. Okay, so my first point here for question 2A, I have located this angle BAD will be equals to angle FAB because these two are actually the same angle, so it's a common angle. Alright, now let's take a look at the next two angles. Now I'm going to find the easier one to explain. So I'm going to focus on the blue color letter, which is D. Let's take a look at triangle ABD and locate the angle for D. So ABD, the angle for D will be this one here. And triangle AFB, the angle B will be this one here. So let me just label this for you. This line here is a chord line. And this line here is a tangent to the circle. So you can see that the angles is between the tangent and chord. So we're going to use this. We're going to use this as alternate segment theorem. Let me put out the second one here. We will be having angle BDA equals to angle ABF using alternate segment theorem. Now the third one, I don't have to look anymore. I just will write down the third angle here. Angle ABD will then be equals to angle AFB, because the sum of angle in the triangle has to be 180 degrees. Therefore, the last angle will be the same. So let me just write down my explanation. So the last one, I'm going to make a conclusion. So I will write triangle ABD is similar to triangle AFB, and we are using the proof of angle, angle, angle. Three angles are the same. That's for question part A. Part B, a circle can be drawn through BC and X with BC as diameter. What type of quadrilateral is EBFC? Give reasons to support your answer. Now I highlighted the important information. Let me take a look at this BC as diameter. I'm just going to draw this line in. If I have BC as diameter and a circle can be drawn through BCX, that means that X has to be on the circle, and therefore I will be having this angle as 90 degrees. The next thing I will be having is this FD as diameter from the previous part of the question. So you have this point FD as diameter. B is a point on the circumference. Therefore, this angle here is also 90 degrees. Now, let me just jot down this information first. I'll be writing angle FBD equals to angle BXC. They are both equals to 90 degrees because angles in a semicircle. Now next, let's discuss about the 90 and the 90. If you can see, I am going to draw a C shape here. So I know that this two has to be parallel because 90 plus 90 is going to give us 180. That will give us co-interior angle. So I'm going to write down the second information. Angle FBD plus angle BXC will be equals to 180 degrees. This implies that the line BF is parallel to the line EC because co-interior angles add up to 180 degrees. Okay, now let's discuss about what type of quadrilateral EBFC is. Since we have the parallel lines, I'm going to extend the line here. So this line is parallel, and we need to discuss about the length. So I'm going to do a discussion because BF is parallel to EC, but the length of BF is not equals to EC. So we have this shape that this one is parallel to here, and since they are not equal, so if I'm going to look at it as a quadrilateral, it has to be a trapezium. So I'm going to answer my question here. EBFC is a trapezium. I'm going to explain the reasons because they have one pair of parallel sides which are not equal. That's for question part B. Question 3, tea is poured into an empty cup. The temperature Tc degrees Celsius of the tea in the cup, T minutes after it is poured, is modeled by the formula, which is written here. Part A, find the initial temperature of the tea. So the word initial, we're going to substitute time equals to 0. So I have Tc equals to 86. E to the power of 0 times this will become a 0. So I'll be getting 86. So therefore, first answer here, I'll be getting 86 degrees Celsius. Part B, find the time taken for the temperature of the tea drop to 37 degrees Celsius. So we are going to set Tc equals to 37. Let's pull this one down here to work it out. 86 e to the power negative 0.06 t equals to 37. We'll divide 86 both sides. So I'll be getting 37 over 86. Next, we're going to deal with e, so take ln both sides. And the last step, to find t, we're going to divide negative 0.06 both sides. So I'm going to write it as 1 over negative 0.06 ln of 37 over 86. And I'll be clicking my calculator. I'll be getting this answer as 14.1. Let's write down the time. So therefore, 14.1 minutes. That's for question part B. C, some tea is poured into an empty cup and at the same time, the same volume of tea is poured into an empty flask. The temperature TF degrees Celsius of the tea in the flask at time T minutes after it is poured into the flask is modeled by this formula here. Where lambda is a constant, the formula for Tc still applies. Part 1 after 1 hour. So you need to be very careful over here. I cannot set t equals to 1. I need to set t equals to 60 because the small letter t here is measured in minutes. After 1 hour, the temperature of the tea in the flask. So I'm setting Tf equals to 82 degrees Celsius. Plugging in this and this number into this formula, I'll be getting 82 equals to 86 e to the power of negative. I'm going to swap this position and write it as 60 lambda. Alright, so dividing 86 both sides, so 82 divided by 86 will be equals to exponent of negative 60 lambda. Taking ln both sides. And the next step, divide negative 60 both sides. So lambda will be equals to negative 1 over 60 of ln 82 over 86. Let me click my calculator. We will be getting 0.000794. That's for C1. C2, using your answer from part C1 means I'm going to use this lambda value. Find the time where the temperature of the tea in the cup is half of the temperature of the tea in the flask. Now let me just jot down the important information here. Temperature for the tea in the cup will be equals to half the temperature of the tea in the flask. So next, let me replace this with that formula. So I'll be getting 86 exponent of negative 0.06 t equals to half. Tf will be this, but by replacing the lambda value from the previous part. Now the next step, we are going to divide by 86 both sides. And I am also going to bring the whole exponent on the right hand side to the left. So I'll be getting exponent of negative 0.06 t divided by exponent of negative 0.000794 t equals to the right hand side, which I have half. Same base, exponent, I'm going to subtract the power, so negative 0.06 minus negative 0.000794. I'll have a t here, and I'm going to check my calculator after subtracting the number. I'll be getting this negative 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. 0.059206. Taking ln next step. And the last step, t will be equal to ln of 1 over 2 divided by this number here. So answer will be 11.7, therefore 11.7 minutes. That's for C2. Question 4. Do not use a calculator in this question. Part A. Use the identity for tangent to A to show that tangent 15 degree equals to 2 minus 3. Now I've written a formula for tangent to A here. Let's think about how can we get tangent of 15 degree. So there's two ways you can try. I have two different angles here. One is A, one is 2A. Let's try. If I let A equals to 15, or the other option, I can let 2A equals to 15 degree. Now if I let A equals to 15, 2A will be equals to 30. If I let 2A equals to 15, then A will be equals to 7.5 degree. I need to make a decision because I do not know what tangent of 7.5 degree is. I know what tangent of 30 is. So therefore, we are not doing this. All right. So let me erase this part here. We're going to let A equals to 15 degree. Let me just rewrite it nicely. Let A equals to 15 degree. I'm going to substitute A into this position. So 2 times of A will be 30. So tangent of 30 will be equals to 2 tangent of 15 degree divided by 1 minus tangent square of 15 degree. Alright, so we know that tangent 30 is 1 over square root 3. I'm going to replace this value on the left. Next, we need to think of how we are going to solve this equation here. So I'm going to multiply this one to the numerator, which is 1. So on the left, I'll have 1 minus tangent square of 15 degree equals to this square root 3. I'm going to multiply by this one here. So I'll be getting 2 square root 3 of tangent 15 degree. Okay, since it's multiplication, I can just swap the position. So I'm getting this one. And this one here, can you see tangent 15? Tangent square 15. It's a quadratic equation, just that you involve tangent. So I'm going to move everything to the right, so I get 0 on the left. I move this one, I'll have tangent square of 15 degree plus 2 sec 3 of tangent 15 degree. And 1 move over here is a minus 1. Now if you can't see, then you can do a replacement. So you can see this is x squared plus 2 sec 3x minus 1, where x is equals to tangent 15 degree. Okay, if you need to, you can do this replacement. If not, I'm going to straight away solve for tangent 15 using a quadratic formula. So going from here to here, to solve for tangent 15 degree, I'll be getting minus b, which is this one here, minus b plus minus square root of b squared, so 2 sec 3 square minus 4 times 1 times negative 1 divided by 2 times a, which is 1. Alright, let's continue doing here. So I have minus 2 sec 3 plus and minus. Okay, so let me just divide this one here. I'll have negative sec 3 on the left. And this one will give you 16. Square root of 16 is 4. 4 divided by 2 will be 2. Now, we have two answers here. One is negative sec 3 plus 2. The other one will be negative sec 3 minus 2. And we need to discuss because tangent of 15 degree, this one, 15 degree, will be in quadrant 1. So quadrant 1, this value will be positive. So therefore, tangent of 15 degree. This will lead you to a negative answer. So I'm going to take this as my answer. I'm just going to swap them around. My answer will be 2 minus square root of 3. So that's for part A. Question 4, part B. Prove that tangent 15 degree minus tangent of 105 degree is equals to 4. Now, from part A, I already have tangent 15, which is this value here. So we're just going to focus on this angle 105. We need to think of something that we know the value. So what angles that we know the value? Let me write it down. We can use 30 degree, 45 degree, and 60 degree. Now let's just work on this 105. I can see that this one will be 45 degree plus 60 degree. So I'm not going to use this. I'm going to use this to add to 105. Now let me just write tangent of 105 here. So tangent of 105 degree can be written as tangent of 45 degree plus 60 degree. So this one, I'm going to use the formula that I've written up here. This angle addition here. So I'm going to apply this formula below here. So I will get tangent of 45. This is an addition, follow addition. So it's addition sign plus tangent of 60 degree. Now I'm choosing a plus here. So this is a plus here, but I'll need to choose a minus down here. So this will be a 1 minus tangent of 45 degree and tangent of 60 degree multiply together. Next line, we know tangent 45 is 1 and tangent of 60 degree is square root of 3 divided by 1 minus 1 times sec 3 is going to be a sec 3. So next one, I will be doing rationalization. I will multiply by the conjugate of this will be 1 plus sec 3. All right, the next line, we will be doing this is a minus b, a plus b. I'm going to write it as a squared, which is 1 squared is 1, minus b squared, square of this is 3. Then the top here is the same thing multiplied together. I'm going to make use of a squared plus 2ab plus b squared. So squaring the first number, which is 1, center will be double of this sec 3, so it's 2 sec 3, and square of this will be 3. So next line here, adding 1 and 3 will be 4 plus 2 sec 3 divided by 1 minus 3, which is negative 2. Next line, 4 divided by negative 2 is negative 2. 2 divided by negative 2 will be negative 1. So I'm going to write 1. So my answer will be minus 2 minus sec 3. Going back to there, putting in again. Here, tangent 15, I'm going to copy back from above. 2 minus sec 3. And tangent 105 is this answer here, which is minus 2 minus sec 3. Multiplying negative into this bracket, I'll have plus 2 plus sec 3. And adding 2 and 2 will be 4. Minus sec 3 plus sec 3 is gone. Therefore, we have proven that for B, the answer will be 4. Question 5. When y equals to 3 cos 3x minus 5 sin 3x, the expression may be written in the form of a cos 3x plus b sin 3x, where p, q, a, and b are constants. Now we're going to first find the first derivative and second derivative from this function here. Let's do a differentiation. So this is split by a subtraction, so we're going to differentiate them separately. The constant is going to leave it alone. Differentiating cos 3x, I'll be getting a negative sine 3x. And chain rule, differentiating 3x, I'll be getting a 3. So do the same thing. Putting 5 aside, differentiate sine 3x, that's cos 3x. Differentiating 3x, that's 3. Let's do a simplification. Negative right first, 3 times 3 is a 9 sine 3x. Minus 5 times 3, negative 15 cos 3x. Next, let's do another time of differentiation. So I'll be writing the second derivative as d2y dx squared. Let's do the same. Constant, leave it alone. Differentiating sine 3x, that's cos 3x. Differentiating 3x, that's the 3. Write down negative 15. Differentiate cos 3x, that's the negative sine 3x. And differentiate 3x, that's 3. Simplification. Negative 9 times 3, negative 27 cos 3x. Negative times negative, that's a positive. 15 times 3, 45 sine 3x. That's for first and second derivative. Let me erase this to continue the next part of the question. Next, let's replace the value that we have found for the second derivative, which is negative 27 cos 3x plus 45 sine 3x. Replacing the value that we have found for first derivative, that's negative 9 sine 3x minus 15 cos 3x. Now I'm going to also replace y value. So I'm going to continue here, plus 14. Y value just from the question. So that will be 3 cos 3x minus 5 sine 3x. This one, just bring it down. I have plus 34 sine 3x. All right, so the next part, if you observe, they want you to write cosine 3x first, then sine 3x. Now let's try to multiply this one in. So this p multiply in here and in here. For q, multiply in here and also in here. For 14, same thing. So I'm going to arrange the one with cosine 3x first. All right, so let's take a look. This is where cosine 3x is. So I have negative 27p. Followed by this one here, which is minus 15q. The next one is this 14 times 3. And that's all I have. So I write a cosine 3x. All right, so the next one I'm going to work on sine 3x. So it will be this p times 45 will give you sine 3x. So I have 45p. For this one here will be negative 9q. And from here, I'll be getting a negative 70. And adding these 34. That's a sine 3x expression. So the next one is we need to show that a is that. So since a, let me just write one more line. A cosine of 3x plus b sine of 3x. We're just going to do by comparing cos 3x with cos 3x. So a must be this. Negative 27p minus 15q plus 42. And next, by comparing sine 3x with sine 3x, so b will be this one here, 45p minus 9q. We're just going to add these two together. So I will be getting negative 36. Now, since they want me to show 42 first, so what I'm going to do is this one here. I'm going to just write 42 first. So 42 minus 27p minus 15q. All right, so that's for question 5, part A. 5b, in the case when a and b are both 0, find the values of p and q. So let me just equate a and b to 0. So for 5b, we've gotten a and b just now. So this is the a value. I'm going to equate it to 0. That's number 1. And I'm going to equate b to 0, which is this here. I have equation number 2. So we're going to solve these two equations. So what I'm going to do is I'm going to take number 2 divide by 3. Let me write in front. I'll be doing this. Number 2 divided by 3. Give me this line here. Let me label for this equation as number 3. And next, I'm going to use this number 3 multiplied by 5. I'll be getting negative 60 plus 75p minus 15q equals to 0. I'm going to explain why I am doing this. So the reason I'm doing this is because I want to make q having the same coefficient. You can do any other way you like. So now that Q has the same coefficient, so I'll be using 1 and 4. Right here, I'm using 1 minus 4. 42 minus negative 60, I'll be having 102. Negative 27 minus 75p, minus 27p minus 75p, I'll be getting minus 102p. Since the Q will be the same, I subtract, that's 0. So over to the right hand side, 0 and 0 will still be 0. 0 minus 0 is 0. So I'm getting this. So few more steps, 102p will be equals to negative 102. So p will be equals to 1. All right. I just want to plug into one of the equation. So I'm going to substitute into number 3. So next, I will sub p equals to 1 into number 3 here. I'll be getting negative 12 plus 15. P will be 1, so 15 times 1 minus 3q is equals to 0. Moving the numbers to the right, I'll be getting minus 15 plus 12, negative 3. So q will also be 1. That's for question number 5b.